Okay, let me first say that what we did in our last class uh, wasn't, the video wasn't available to me until yesterday evening. And that's the editor I'm using does some pretty bizarre things. Not blaming it on the editor. I should have double checked it by going to the site and clicking on it, okay? I'm sure I had it right. But what happened was all the material from last time went into a file that had a slightly different name than it should have. There's a backup file, okay? Then it looked just like the regular file. And actually, my editor only showed me the name of the regular file. I'm not going to blame it on the editor, but there is a complication. I'm not completely stupid, just partially. I should have checked. Take a lesson on that and be sure you're checking your work, okay? And I'll try to do the same. And that's exactly the responsibilities on me because I didn't double check. Um, okay, so just kind of reviewing some of the stuff we did last time. Um, Square and shape. So there are my four boundary lines. Everybody knows those. Then I go ahead and kind of emphasize the rectangle. Then I recommend that your dotted lines go a little further from the rectangle so you have some room within the rectangle to draw your graph and work, and you're not always drawing lines over your labeling and everything. Okay, label the window outside the window. All right, then vertically, we divide in the middle. Now that's between x equals 0 and x equals 4. So we might as well say, okay, that's halfway, that's x equals 2. Then we go halfway from the right edge to the center. Now, in the problem sets you're working, I gave you these instructions very explicitly. So if you haven't read through them, and you might not be easy to read. Okay, some people are better at pulling things out of writing than they are at doing things they see. Okay, and I'm just the opposite. I sit in a class, and after about 3 minutes, I'm thinking my own thoughts, and I'm not following what's going on the board. So I go dig it out of the textbook. Okay, it worked well for me. I didn't feel like I was making good use of class time because, I was just getting little impressions. But I noticed when I started skipping classes, my performance went way down. So I kind of needed both. Okay. So everybody has modes. Some people are better at picking it up when it's being explained. Some people are better at picking it up out of the text. Whichever is your preferred mode is fine. You've got the videos. You can replay the explanations if I post them in time. Okay. Anyhow, okay, here we are. Okay, so here's x equals 2, halfway from the right edge to the middle. X equals 3, halfway between 2 and 4. Halfway between 2 and 3 is x equals 2.5. Then over here we get x equals 1 and x equals did I really say what I thought I did? Okay, yeah, that's good. Now, the thing that's bad about it is I said x equals -2 and x equals 2. So I've got to erase my x labelings. The picture's okay. So let me label the x's as I should have. X equals -2, x equals 2. Halfway between -2 and 2 is 0. Halfway between 0 and 2 is 1. Halfway between -2 and 0 is -1. Then halfway between -1 and 0 is -1/2. And halfway between 0 and 1 is +1/2. So those are my x values. The type 2 graph, type 1 and type 2 graph, we start at the top and go halfway to the bottom. Then we go halfway from that last line to the bottom, and people know this, okay? And we have this one. Now, for type 2 graph, we got to have 5 lines here. For type 1 graph, 4 lines. Okay, for the type now these are labeled kind of small. Y = 2, Y = 1. Halfway between 1 and 0 is 1/2. Halfway between 1/2 and 0 is 1/4. And then halfway between 4th and 0 is Y = 1/8. That's the lowest line. Okay? For the exponential function, we don't need that 5th line. Okay? They got to know the rules for doing this. You got to be able to draw these quickly. Okay? You got to practice it. So when we're talking about an exponential model, you've got to be able to quickly get an exponential graph down there. It doesn't take long. I'll demonstrate that. Okay? How long did that take me? More or less than an hour. Well, less, right? More or less than a minute, less. More or less than 10 seconds, probably a little more, but probably not 20. Now, labeling it, just depends on how quickly you write. If you practiced it, you know. And of course, depending on the numbers, you might have to do some arithmetic. Okay? You should probably be able to do the arithmetic in your head between -2 and 2 and between 0 and 4. Okay? Now, one of you did the reciprocal graph, okay, instead of square graph. They're actually a little tougher graph. So that's okay. Except you would have used different boundaries for that one. Okay, for the toolkit reciprocal graph, but it's okay. Now, the squaring graph, here, 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 and here. Over 1, down 2, over 1, down 2, over 1, down 2, over 1, up, over 1, up 2, over 1, up 2, over 1, up 2. That's it. Now, I'm not going to spend a lot of time saying that again because we did it in detail. So check out the video. Everybody understand? So you're going to be able to do that quickly and the reciprocal graph. Okay. And I've done the reciprocal graph. It's in the videos. Okay. One thing I'm working on is in the AI summaries. Has anybody looked at the AI summaries? Any good? I think they say what need to say. Should they be more detailed? Maybe a little. Okay. Because I can ask. I mean, AI is doing this, and AI is doing a good job of it. You see that sometimes there's stuff in italics. That's what I had. Sometimes I got to correct it. Once in a while, the AI screws up a little bit. You got to watch it. In another year, it's going to be 10 times as smart as somebody who's 10 times as smart as I am. Okay. Because it's a little scary. The last version of ChatGPT wrote itself. Okay. That's really scary. That means it's going to be able to get smarter exponentially. You know what that exponential curve looks like, and it keeps getting steeper. Goes out of sight. Okay. Learn to use it. And by use, I mean, and I don't need to tell you because you all are obviously doing your work honestly. Also, one reason I started with the stuff I started with is you can't really use AI to do these problems. If they don't know the context. You would have to understand the context well enough to explain it to AI in order for AI to be able to give you any information how to do the problems. Now we're going to be getting into the text. Ahead of next week, we start the text. Okay. Lay all the groundwork, and then we start working through the text. All right. We want these pictures. We have to have these pictures because these pictures are quicker. They give you understanding better. There's a example that I was wanting to do today, but we're going to have to take a little extra time in some of the stuff. I'm not going to be able to do it. It is the ChatGPT model. They're measuring it. And I've got the information, but I don't have it in my head. But the last time they measured, ChatGPT could do almost in an eye blink what a top-notch human being could do in 5 hours. Okay. And that's doubling about every 6 months, maybe 4 months. Okay. That means in another 6 months at that rate, it could do 10 hours of work. In another 6 months, all by itself, another 6 months, you double that, you get 20. How long before it can do a lifetime's work for one person? And then how long at that rate before it could do a lifetime's work for every human being if every human being was a genius? Okay, well, it'd be a while, within 20 years. And then what are we going to do about that? We're not going to be able to control it. So we'd better hope it likes us. And hopefully we're training it in such a way that it likes us. It's a little more complex than what I'm saying, but it's there. Okay. And of course, AI is going to interpret my transcript, so they're going to know who to kill first. Now, the equations of stress. Is it x minus 3 or x minus 8? Yeah, it is. It's plus 3 and x minus 8. I illustrated how to write these out last time, okay? And nobody really got the details, but some were close. And others show me, yeah, you can do some algebra, but learn to do the algebra of this by doing it in the form I say, which is, the logic is, if this times this equals 0, then either this has got to be 0 or this has got to be 0. One of them's got to be 0. So we can write x plus 3 equals 0, x minus 8 equals 0. One of them has to be 0. So this one or this one, we write this step, okay? Always write this step because then you have a form that you're used to that makes it easy to solve, or at least to break down any equation of this type, okay? So x minus 3 equals 0. Well, you can add negative 3 to both sides, and you're going to get x equals 3. And here you're going to get x equals 8. The solution set. Let's see, this should be x equals negative 3. I said it too fast, and I just wasn't thinking. Okay, I should have done the steps. So there's your solution. x minus 3 multiplied by x minus 8 equals 0. So x minus 3 equals 0 or x minus 8 equals 0. You've got to write out that step. Okay? Does that make sense? It's easy to do. Just practice doing it. Okay? Then we have what was the next 2x plus 8 and x plus 2. Minus, no, they're both plus. Okay. So quantity 2x plus 8 multiplied by the quantity x plus 2 equals 0. This times this equals 0. So this is 0 or this is 0. In other words, 2x plus 8 equals 0 or x plus 2 equals 0. 2x plus 8 equals 0. I'll do the steps. We take negative 8 equals negative 8 and add that to 2x plus 8 equals 0, and we get 2x equals negative 8. We divide both sides by 2. Get x equals negative 4. If it's a more complicated equation, that's okay. If you know how to solve that more complicated equation, you just solve it. If you don't know how to solve that complicated equation, then you say, hey, I don't know how to solve that thing. So question mark on this one, but maybe I can solve this one. So I can at least get one solution, okay? I mean, if I write down x to the fifth minus 7x to the fourth plus 5x cubed minus 4x squared plus 3x minus 297 equals 0, I can't solve it. You can't solve it. There's a 50-50 chance in that, I don't know if it's really 50-50, that nobody can solve it. Okay? Probably higher than 50-50. If I write down an equation, I mean, yeah. Uh, so anyhow, there's my solution set. You got to use this form. I won't say you've got to use this form, but if you don't use this form, you're probably not going to get it. It's the simplest form. It says everything that needs to be said. Okay? Now, x squared equals 36. X can be the square root of 36. Or x can be the negative of the square root of 36. Same form, two possible solutions. And there's a strong tendency for people to only get one of them. So the x equals 6 or x equals negative 6. Alternative, I recommend that you do this every time, okay, until it's really sinks in. That might take a couple of weeks, but the alternative, you write x equals plus or minus the square root of 36, which is just what you've done here, means x equals square root of 36 or x equals negative square root of 36. The solution set either way is x equals, is just a set negative 6, 6. Now, if we have x minus 4 squared equals 25, well, if something squared equals 25, that's something. Well, let me write it out. x is the square root of 25, or x is negative square root of 25. So that x minus 4 equals 5, or x minus 4 equals negative 5, so that x equals 9, or x equals negative 1. Then you check. You put 9 in here. What's 9 minus 4? It's 5. What's 5 squared? It's 25. X equals negative 1. If you plug in negative 1, you get negative 1 minus 4, which is negative 5. Square that, you get 25. Now, I said all this with similar problems last time, but of course, you didn't have a chance to digest the video. So you're going to need to digest that video and this one, okay? All right. Well, that reviews some of the high points of what we did last time. Now, give me a second to okay, let's make sure we understand what I mean when I ask you to do a table for one of these functions. And right here is the points that you would use for your squaring shape. Okay, just labeling a table for this. That means I take these points that I use, my construction points, okay? Just the construction points. That's really all you need to get the good shape, because once you get that, some are doing really good shapes and some of you need to get the grids right down, okay? What are the coordinates of this point? X equals negative 2, y equals 4. X equals negative 2, y equals 4. This point, x equals negative 1, y equals 1. This point, x equals 1/2. Sorry, x equals negative 1/2, and y equals 1/4. And we list the others. X equals 0, y equals 0, x equals 0 line, y equals 0 line. Then 1/2, 1/4, 1, 1, and 2, 4. There's the table. Now, another thing, I'll just kind of now I'm adding something. This is the table. That's it. Okay. I'm adding something. So I'm going to do it in a different color. Okay. This is y squared plus 3. So what I'm doing here is like I'm feeding x into this function. And then I'm taking the y value and squaring it and adding 3. Okay. Well, y squared plus 3 is going to give me 19 here. 4 squared is 16, add 3, you get 19. 1 squared is 1, add 3, you get 4. 1/4 squared is 1/16, and you add 3 and you get 3 and 1/16. If you square 0, you get 0, add 3. And then these three numbers are the same as these three numbers. So you're going to get the same numbers again. And this is, let's say, Z equals. I'm just going to use a word here that you're going to be seeing this soon. It's a composite of the squaring function y squared plus 3 function. Now you don't, it's not required that you know this for the next couple of assignments. It's a good idea. So, give it a little thought. Just get that word composite and understand that what you do with a composite is you take x equals -2, and in this case, you use the graph to see what the squaring function gives you, which is y equals 4. Then you take that y equals 4 and you do something else with it. In this case, you square it and add 3, right? So you have two functions. This function acts on the output of this function. So the output of the first function is the input of the second function. Okay? It takes a little thinking to get used to the idea, but it's really important. Most of the functions we deal with then are composites of simpler functions. And the simpler functions are mostly the functions you've already seen. Okay. Let's say we have y equals x minus 6 squared. And I want to do a graph of this function. And I want to do it by making a table. Well, I'll tell you the table that I would recommend you make. Right here's the table. So what do you get for y if x equals 4? Can you show me with your fingers? Think about it for a second. Show me with your fingers. Can you see what number you get if you plug in x equals 4? Best if you do that without a calculator, but if you need to use a calculator, go ahead. Okay, if you plug in x equals 4, 4 minus 6 is -2, right? And then you square that. What do you get if you square -2? You get 4, okay? So you said 4, so you said 2 because you got to this point, hadn't quite got to the point of squaring it, I think. So you're on track. Okay, so I get 4. And here's the calculation I use, right? Okay. So see what you get for 5 and 5.5 and 6. It's going to give you about 2 minutes. Calculate some of these. See how many you can get. And you can come down to these numbers too if you want to. I don't care which numbers you use, but go ahead and fill in a few lines of the table. Okay, everybody's doing really well here. If it's 5, you get 5 minus 6 squared equals -1 squared equals 1. Now, if you just directly go and punch it into a calculator, you're not thinking these symbols, okay? But if you are thinking those symbols, just using the calculator, well, when you do these for homework, show me all the details. Write out the details because that helps you remember the details, okay? So you get 1, here you get 1/4. Now that's 5.5 minus 6. That's -1/2 squared, which is 1/4, etc. Then you're going to get 0, 1/4, 1, and 4. Okay? Now let's look at what that means in a window from x equals 4 to x equals 8 and y values go from 0 to 4. Okay, so there's a window that corresponds to this table, right? And if we divide that window up into a type 2 graph, and why would you use a type 2 graph? Because this is a squaring function, but with something besides just x. Okay? We divide this thing up. So we do the type 2 graph, which includes this y equals 1/8 line. And the 1/8 line is just there to skip. Now, if we mark the points over 1 down 2, over 1 down 2, over 1 down 2, over 1 up 2, over 1 up 2, over 1 up 2. If we make a table for this function, it's going to be exactly the same table we just made by doing the calculation. Okay, now I kind of slopped that down there, but it's all there. I've labeled all the construction lines in the usual manner. Like, how do I know that this one is x equals 6? It's halfway between 4 and 8. Okay, if you got to add 4 and 8 and divide by 2 to get 6, go ahead. Got to use a calculator to add them, divide by 2, go ahead, but try to visualize it because the numbers are small. You should be able to kind of visualize that 6 is as far from 4 as it is from 8, and it's in between. Okay? But there's the picture. Now, how does this relate to the graph that we made here? Well, it's going to be kind of tough to do this, but let's see if I can get these two graphs up here in a way you can see them both. Okay, to compare this graph to this graph, it has exactly the same shape within its rectangle. What's the difference? Well, the difference is the point where x equals 0 and y equals 0 on this graph is right here. The corresponding point in this graph is right here. And I can make the statement, the origin 0, 0 of an XY coordinate system is at the center of the low edge on the graph of x squared Now, it might be a little hard to read that. I'm saying for y equals x squared, the origin, which is a point 0, 0, is at the center of the lower edge. This is the x squared graph.
What do you play?
How do I know it's the x squared graph? Well, because if I make this table over here by calculating, if I just square the x's, these are the numbers I get for the y. Okay? Now you've just made a table for one that's a little harder where you got to subtract 6 from the x, and you get a table. You notice that the y values are identical to what they were here, which is why you can use the same grid, but with different labeling. Okay, y still goes from 0 to 4 as it does here, but now x goes from 4 to 8 instead of from -2 to 2. So we say that this graph red dot that goes at the center of the lower edge is at x equals 6. Now, this is written small. You probably can't read it. I've expanded this statement a little bit. For y equals x squared, the red dot at the origin 0, 0 here is at the center of the low edge. And the red dot for this graph is at the center of the lower edge, but that's now at x equals 6. So the red dot has shifted from x equals 0 to x equals 6. Okay, y is still 0. That's a transformation. What do you think would happen if we did y equals x minus 20 squared? We're still just squaring x, but the x we're squaring is like x minus 20, and that's not a good statement. We're squaring x minus 20 instead of x. If we square x minus 20 instead of x, the red dot would appear at x equals 20, y equals 0. Does that make sense? It's because in order to get 4, 1, 1, 4, 0, 1, 4, 1, 4, x minus 6 has to equal -2, -1, -1, half, 0, 1, half, 1, 2. You see that x minus 6 gave you the -2, Here, x minus 6 gave you the -1. Here, x minus 6 gave you the -1/2 that you squared in order to get the familiar numbers. Does that make sense? Okay, there's a rule there that says if you replace x by x minus 20, it's going to take this graph and shift it 20 units to the right to where x equals 0 becomes x equals 20. And all the other numbers go along with it. Now that's a big idea. It's an idea that it's very difficult to get pre-calculus students to understand, which is why we're talking about it now. You're going to encounter it again in 2 weeks in the text. Okay? So we're trying to prepare you with some simple examples and some exercises for what you're going to see in the text, because %, 95% at least of pre-calculus students come out of the course not remembering anything they learned in chapter 1. Okay? Because they weren't ready to learn it. The reason we're doing all these daily exercises, there are 11 of them right now, but I might modify some of that. But we're up through 8 at the beginning of next week. It gives you a foundation for understanding things that pre-calculus students never understand. Okay? Now, when I say never, yeah, occasionally we get pre-calculus students who are capable of going on to a PhD in mathematics. Most people capable of going on to a PhD in mathematics have already had pre-calculus and even calculus in high school. Okay? But yeah, we encountered one just a few years ago. Came to me in the hall and said, I'm going to be taking your pre-calculus, and my goal is PhD in mathematics. Well, I don't judge. In my mind, I said, chances against that are high. Well, by the time I got to know that student and his work, he could have coasted to a PhD. I mean, it was going to take him about 7 or 8 years, but that's what it takes. So we really need to teach the pre-calculus in a way that people who are going to go on in STEM fields can understand, and that people who aren't going to go on in STEM fields still have a good picture of, a useful picture of mathematics, okay? And the transformation thing is a big deal. So that's why we're doing this. A little bit of a digression there. I find that I get students in the more advanced courses who've already had a year of calculus and linear algebra and still don't understand transformations. Okay. And a bunch of other stuff. And it does get in their way, even though they're smart enough to put it together. You don't want them stumbling over it. So we're trying to remove stumbling blocks here. Okay. Here's your table for the squaring shape, right? And here's the squaring graph. Now, for reasons that I'll explain later, they're difficult to understand, but let's confine our attention to this much of the table. Okay? And what we're going to do is we're going to find an inverse function corresponding to this part of the table. Now, if I draw, I'm not going to label it. But if I draw my usual square graph with the red dot at the origin, and this is y equals 0, this line is y equals 4, this line is x equals -2, this line is x equals 2, same picture that we've had. Okay, 1, 2, 3, 4, 5. We've got 5 of them in there. Just taking these points, 0, 0, well, that's x equals 0, y equals 0, and that's right here. Then x equals 1/2 and y equals 1/4 is right here. And the next point is here, and the next point is here. And I'm not drawing this very well, but right there's my curve. And it's just the right-hand half of a curve like this, right? Because I've excluded all this. So my table is here. That's a table for x squared. Now I switch x and y. So I write my y values in the x column and my x values in the y column. Okay. And now I graph these points. So let's say I'm going to put a colored box around this, and I'm going to use this color for the points. Okay, I'm going to get 0, 0. That's the same point I started with. But then I'm going to get 1/4, 1/2. Okay, now 1/2 is on this line, and 1/4 is between 0 and 1/2. So I would get a point here. And then 1, 1. Well, I've got that point on the graph. And then I've got to go all the way out to 4. So I'm going to have to extend my rectangle a little bit. I'm going to have to extend my rectangle out to x equals 4. And I'm going to get y equals 2. Well, y equals 2 here. So that's going to give me a point here. And I can sketch that curve. Does that make sense? I just swap my x's and y's. So what happens is this shape gets kind of flipped over and then rotated down here. Okay. This is the inverse function. See, we've got a formula, square root of x. I'm going to have to do this too fast for you to digest, so make a point to look at the end of the video and see. If y equals 2x plus 4, the inverse, you swap x and y. You make the y's into x's, you make the x's into y's, which is exactly what we did with this picture, right? We solve this for y. Okay, we got x equals 2y plus 4. We add -4 equals -4 to both sides. We get x minus 4 equals 2y. Then we solve for y, divide both sides by 2. We get y equals x minus 4 over 2. These are what we call function inverses. Okay, the process for doing a graph is simple. If you got a table, you just reverse the columns. If you've got a formula, you switch x and y and solve for y. It's fairly simple. You might see one where you got y equals, say, 2 over x plus 5. Switch, and you get x equals 2 over y plus 5. And you got to solve this for y. And that gets a little more complicated, but you might see that in set 8. If you get down to this point, if you just do this much, I'm going to be happy with it. If you can solve this for y, I'll be real ecstatic, but I'm going to show you next time, okay? Because we kind of ran out of time. We had to spend a little time at the beginning to make sure we knew where everybody was. And that was more important than learning to solve this. You just multiply both sides by y plus 5, and then everything gets pretty easy, okay? But you don't have to remember that, but get that much, okay? Because the next assignment is going to build on that idea. And at that point, you're going to be pretty close to being ready to sail through chapter 1 without stumbling on anything. That's what we're really trying to get to. We're also building a foundation for all the later chapters.